This confusion is about the electric field in conductors. If we see electric field equals 0 inside conductors. Okay, this is generally true for stationary charges, means electrostatics. True for electrostatics. Okay, but when we deal perfect conductors, by Ohm's law, J equals to conductivity and multiply by electric field. So this implies that the electric field is equal to J divided by conductivity. Okay, now J divided by, what is the value of conductivity for perfect conductor? It is infinity. Okay, conductivity equals to infinity for perfect conductors. So this value approaches to 0. Okay, so the J equals to, electric field equals to 0 for perfect conductors. In practice, metals are such a good conductors that the electric field, for example, we have a metal. Okay, they are such a good conductor that the electric field required to drive current in them is negligible because there is no resistance. So when there is no resistance, a small push is enough. Okay, for example, this is electron. Okay, and this doesn't encounter any resistance. So when we apply a force F on them, okay, this will move. Okay, but when there is a resistance here, for example, where here is a resistance, where it will collide here and stop. Okay, but when this there is no resistance, okay, this will move slowly. So it generally makes sense that the electric field required for conductors to drive current in them is very small. Okay, and for perfect conductor we can say that the E is 0, electric field is 0 in them. But in ordinary and practice we cannot say that electric field is 0, but it is very small and we can neglect it and we can say it is 0. Okay, thank you.